Monolithic SQL pipelines can fail in unpredictable ways. And worse, they can quietly degrade your data quality without anyone noticing. In this video, I'll show you that failure mode in a real daily pipeline. Then I'll refactor it into dbt models with tests so you can catch issues earlier, reduce blast radius, and debug faster. Hi everyone, my name's Rob from RobOps, and today I'm showing how dbt can turn a fragile SQL pipeline into something resilient and testable. Before we jump in, quick overview. dbt is a transformation tool. It doesn't extract data and it doesn't orchestrate schedules. It focuses on the part where you take raw tables and transform them into clean, analytics-ready tables using SQL. The key idea is instead of one giant query, you build a graph of small models. dbt knows the dependencies, runs what needs to run, and it lets you add tests so bad data gets caught early. So here's the plan. We'll start with a monolithic SQL pipeline, watch how it fails or silently degrades our data quality, and then we're going to rebuild it with dbt. We're going to see how the failures are now going to be much clearer, isolated, and easier to fix. So the scenario we're going to be simulating today is that of an organization that's monitoring the relationship that students have with social media. We're going to be using this data set from Kaggle that's available online and linked in the description. And we're very concerned about how social media impacts the students' ability to succeed with their education. As a result, we monitor the daily stream of social media data and make decisions based on the data on how to support students. So now that we're in the code view, we're going to open up our project directory called Airflow DAG experiments. And you'll see there's a bunch of different folders, but the ones that we're going to be focusing on for today are really just the DAG folder, the data set, and later on the dbt folder. So if I open up the data set, this is my social media data. If I click into this, it's about 700 rows of information from the sample data set downloaded from Kaggle. Now, if I go to the DAGs, I'll notice I have a SQL folder and then various DAGs. For the purposes of the first part of this experiment, I'm going to open up the social monolithic DAG, and we're going to scroll to the top. And basically, you'll notice it's like any other DAG definition. We have the DAG decorator here, and then we have the monolithic SQL. And here's our task. And so we're going to start by loading the raw social data. And so this is just basically going to check if the tables exist. If they don't, create them. If they do, drop them, just so we have a fresh run every time. And then we're going to run a create table to create our table. And then we're going to copy some of the table over to our data path. Finally, we're going to run this monolithic transform. And this is what's going to actually execute our monolithic SQL. So if we want to see what the actual SQL is, you can go to the SQL folder and you'll see social monolithic transform. And if you go in there, this is our almost 100 lines of SQL that's going to create our social staging data. And so this is going to basically create a table that cleans up the data from our raw data set. Then we're going to create an intermediate table, which is going to clean up and basically enrich some of the data with some case values. And then finally, we're going to create some of our MART tables. And so we're going to create platform usage, addiction by demographic, and then sleep versus usage. And so these are the tables that are actually going to be used for our analytics. So now that we see the definition, we're going to go over to Airflow and we're going to see how our DAG appears in the Airflow UI. And so in order to do that, I'm just going to switch back to the Google Chrome view. And here we are in the Airflow UI. And now I'm just running Airflow locally, so all of my DAGs will run directly from my machine. So if I click DAGs and then I search for DAGs, I think what I'm looking for is student monolithic transform, and here it is. So here's the DAG we just went over. And as you can see, there's two steps. One is just loading the raw social data, and then we're going to actually apply the transforms. And so in order to kick this off, we're going to click trigger. And essentially this is going to trigger an Airflow DAG to pull our data set from our project directory, and it's going to run it through the data pipeline that we've defined. Once it runs it through our data pipeline, it's going to insert it into a Postgres database that we have running locally. So in order to do that, I'm going to click trigger, and that's going to kick off our DAG. Now, we only have about 700 rows of data, so this shouldn't take very long to run. As you can see, our run's completed. And so now we've essentially populated our Postgres database with our social media data. Now in our scenario, this is just something that's running from a data set, but in real life, this could be a data set that gets refreshed every day. And so every day we get a new set of data for that day for our students. And so this pipeline would essentially run every day or anytime there's new data. And so this data would constantly be added to our database for analysis. So now I'm going to hop over to our database viewer and see how we can visualize some of this data. So now I'm over here in dbeaver, which is just an open source tool that allows us to run queries against our database. And so the first thing I'm going to do is just simply run a select all statement as a count against my staging table to verify the number of rows. As you can see, the number of rows, 705, matches our CSV file, so we know that our DAG ran as we might expect it. And so from here, I'm going to start copying some queries in so that we can get to know our data a little bit better. If I just go down here, I'm going to copy in 3 queries. And these 3 queries are going to be the basis for our experiment. The first one is going to look at the platform usage across TikTok and order it by students. So if I just select this and run, we can see that the most used platform for the country US at the undergraduate level is TikTok. And we can see the average daily usage hours about 7.2, and the average addicted score is 9 for about 16 students. And so you can see various data across different countries and academic levels and see how TikTok is being used across these students. Now, if I look at a segment like high school, and here I'm going to look at academic level high school, where the most used platform is TikTok. And as you can see, in high school, the average use is about 5.2, and the average addicted 7.6 for about 8 students, where TikTok is the most used platform. And finally, I'm going to look at the high-risk cohort size. And so if I go here and run this query, we can see that the high-risk cohorts for TikTok across undergraduate, graduate, and high school are as is shown. And as you can see, high school is quite low at 25. So what I want to simulate here is us getting new data on a daily basis. And what I'm going to do is actually inject some bad data. And this data is going to significantly skew some of these results, and it's going to actually tell a different story. And unfortunately, our monolithic pipeline is not going to catch some of this bad data, and it's going to present the data to our customer. So to do this, I'm going to hop back over to our code view, and I'm going to open up our data set. And because we're not running on a daily basis, I'm simply going to copy in a new set of data. And as you can see, some of these average daily usage hours is extremely high. And in some cases, it's going to end up skewing some of our data. I'm going to go back to Airflow, and I'm going to rerun our DAG. And so in order to do that, I'm just going to go into trigger, and I'm going to just trigger this DAG. And this is going to rerun our pipeline. So now that our pipeline's completed, we can now go back to dbeaver, and I'm just going to run this count again. And I'm actually going to run it in a new tab because I want to preserve the old results. So instead of 705, we now have 745. And now what I want to show is how this bad data impacted our results. So if I go here, and I'm simply just going to run the same exact query. And as you can see, the same data for USA High School, the average daily usage hour is now 10.3, up from 7.2. Similarly, the average addicted score went down, and the student count went up by almost 25. Now if I go down and look at the segment spike and run this query, we can actually see that the number of students also went up, but so did the average addicted score from 7.6 to 8.3. Similarly, the average usage skyrocketed from 5.2 to 9.5. Finally, if we look at the high-risk cohort size, we can see that high school actually spiked to the top. Where it was previously 25 and undergraduate was the highest, high school is now the peak. And so as you can see, this data really turned our analysis upside down. We now have very different results, and it would trigger many different downstream actions to understand why our high school students are being impacted so dramatically. And the sad part is this data is not adequate data. And our pipeline should have caught that. Providing reliable data to our customers is of utmost importance. Unfortunately, Monolithic SQL does not allow us to build reliable and robust pipelines that can handle adverse data. And so now we're going to see how using dbt can help us look at this data before ingesting it and help us get around some of these problems. So now that we're back in the code view, we're just going to show essentially how we've set up dbt. And so as you can see, we have our DAGs, we have a dbt folder. And if I open up this dbt folder, we're going to see a profiles.yml, and this is just essentially how our target is going to communicate with our data source. In this case, it's a Postgres running locally. Now, if I open the social demo folder, I'll see a few important things. I'm going to see models. And these models are how dbt breaks up different views. We have a staging set of models, which is essentially responsible for cleaning the data, similar to our staging table in our monolith. We have our intermediate tables. These are going to be models that allow us to enrich the data. And then we have our marts, which is essentially the analytics ready models that we're going to use to visualize the data. Now, you're going to also see this dbt project.yml. And if you go in here, you're going to see essentially some directions for the model paths, along with some target paths. And we're also going to show how we plan to materialize different staging, intermediate, and mart models. So in this case, we're going to materialize our staging and intermediate tables as views and our marts as tables. Finally, I also want to show the tests. And as I was mentioning before, we do have the capability to run tests against this data. And so if you look into addicted score range, we can see select all from staging students where addicted score is less than 0 or addicted score is greater than 10. And so these tests expect to return null. If they return anything that's not null, they're going to fail, and we're going to be notified immediately. The final thing I want to draw your attention to is our schema. And so our schema also is a form of testing. So we're actually able to run tests against our schema columns. And in this case, student ID, we expect it not to be null, and we expect it to be unique. If we do come across data that fails this validation, we will be notified and will be able to exactly identify what went wrong and where. If we move up to DAGs, we'll notice that we have a social dbt DAG. This is the DAG that's going to be responsible for running our dbt commands. As you can see, it looks very similar to our monolithic DAG. We have our DAG decorator that has the DAG details. And then if you go into the definition, we essentially are going to run three things. dbt seed, because we need to basically pull the data in. Then we're going to run dbt run. This is going to take all of our models and the directions from some of our instructional YAMLs, and it's going to create the tables that we need for our experiment. Finally, we're going to run a dbt test, which is going to run tests against all of our data. Now I'm going to pop over to Airflow, and we're going to see where our DAG is currently active. So from here, I'm going to go back to our DAGs, and I'm going to just look up social. And here I see social dbt models. And as you can see, we're going to seed the data, we're going to do a dbt run, and then we're going to do a dbt test. I'm going to trigger a run, and we're going to see dbt in action. As you can see, the seed ran along with the run and the test. Now, if I move back to dbeaver, I can verify the data that I just put into my table. So I'm just going to remove this, and I'm essentially just going to do a count from my social DBT staging students. If I do that, I can see 705, which means my DBT model loaded the staging data correctly. So now I'm going to copy in the other queries that we just ran previously against our monolith against our DBT models. And so for the platform shift, I'm going to just run here. We can see that the data looks identical to our old data. I'm going to run against the segment spike, and we can see high school well within our means. And then finally, we can run the high cohort, and we can notice that high school is okay. So the data is exactly the same, but we've compiled it using DBT instead of our monolith. And now when we inject the bad data that could be simulated by a daily run that brought in incorrect data, we're going to see the power of DBT. So starting from the data, we've copied in our bad data, and now we're going to run our Airflow DAG. And so if I click and go back to our Airflow UI, and I go into our social DBT model, I'm going to click trigger, and I'm going to do a single run, and we're going to see how the DAG performs. So our data is seeded, our DBT runs, and then our tests. So as we can see, our tests failed, and if I look into our tests, we should get some more information. And so here we'll see all of the schema checks that are happening. And we can see them started, and we can see the first one failed. And then we can go through and 3 of 15, and then we'll start to see other failures. So we see unique student ID failed, sleep hour range failed. And so what we're seeing is a variety of things being checked against our data. And so if I go back to our code view, and I go into some of our schemas in our models directory, we can see student ID not unique. And so if I go into here and I look at some of these data points, we can see 905 appears more than once. And so this is automatically going to invalidate that data. In addition, we have our tests themselves, and you can see the addicted score range. Anything greater than 10 should not exist. And similarly, sleep hour ranges and usage data. And so these tests allow us to bring some sanity checks to the data and make sure that nothing is being loaded into our data sets that would provide the wrong signal to our customers. And so as we can go back to Airflow, we actually have a really good idea of what we need to go and look at. We can see all of the failures, and then we can go and check our data, and we can see exactly what we need to do to clean this up with our upstream partners. And so the most important thing here is if we go back to our dbeaver and we run the value with our bad data, we can tell the most important thing, which is the numbers haven't changed. And so the bad data that was injected into our pipeline was caught, and it was errored, and we didn't publish any data that would create misdirection across stakeholders. So as we can see, the failure to properly catch bad data resulted in large swings in our results. We didn't catch some of the data quality issues, which resulted in our data appearing in our reporting. As a consumer of this data, these swings would have triggered investigations and programming decisions that impact real dollars of our business. And sure, you can add sensors and validations to the monolith to prevent some of these outcomes. But DBT turns this whole workflow into a system. You get structure that's easier to change, reliability checks you can standardize, speed from incremental and selective runs, and visibility through lineage and documentation. The result is less guesswork, faster iteration, and fewer surprises in production. DBT is more than just tests. While this video highlighted the benefits of them, as your datasets get bigger, structure, speed, and visibility become critical to your team's workflows. If you found this interesting or would like to learn more about these areas, feel free to comment below. And like always, if this is something that you enjoyed or you'd like to see more, please consider liking and subscribing. It really helps my channel out a lot. Thanks, and have a great week.